Okay, so for today's video, we're going to be looking at the antiderivative of 4x to the power of 3 divided by 2x plus 3. So something I feel like we should note first is that we have powers of x in both the denominator and the numerator. If we look at the numerator, we will notice that the exponent here in the numerator is greater than the exponent of x down here. When the exponent of the numerator is greater than the exponent of the denominator, that is often a telltale sign that we need to use polynomial long division. And that's exactly what we're going to do. So let's rewrite it just like how we would normally write a long division equation. We put our numerator inside of the house and our denominator on the outside of the house. And then this is where we can start dividing. So just like in long division, we need to figure out, okay, how can we cancel out the pretty much first term that we could? With 4x to the power of 3, we can cancel that out by multiplying 2x by 2x squared. Because if we do that, that will get us 4x cubed. Now, since we're dealing with polynomials, we need to multiply this value of 2x squared by the other part of polynomial as well, which happens to be positive 3. So 3 times 2x squared gets us 6x squared. And then just like in normal long division, you have to subtract each time. And you'll notice that if we do this, our 4x to the power 3's will cancel out, become 0, and then leave us with this, because this has nothing to cancel out with. So we are left with 6x squared. And then we pretty much do the same process until there are no more x's in our numerator inside the house, pretty much. So what I like to do to make things a little easier to keep track of, I like to add in little placeholder zeros. So how you do that is that you just add 0 times x to the power of whichever is the next lesser power. So since we were doing x to the power 3 here, we're going to do x to the power 2. Just so that way it aligns with this negative 6x to the power 2. So if we do this, we should look at our equation and be like, okay, what's going to cancel out now? Well, can we multiply 2x plus 3 by to cancel out negative 6x to the power 2? We can multiply by 3x because 2x times 3x gets you 6x squared. And if we do 3 times 3x, because you can't forget that we're multiplying by the whole polynomial, not just parts of it, we'll get 9x. And here's another thing that we should note is that when we are doing long polynomial division, you should always pay attention to your signs, because they definitely will affect what your value is going to be in the end. In this case, we know that every single time we're going to be subtracting, right? And that subtraction sign acts kind of like a multiply, like being multiplied by -1. It will distribute, which means if we just take normal positive 3x, we're going to end up with like -12 in the bottom down here, which is why we need to multiply by negative. So that way, by the end of this, our negatives will cancel out. You saw me fix, 2x times -3x will become negative 6x squared, but 3 times negative 3x is just going to become negative 9x. This sign gets carried through, so we're left with positive 6x squared and positive 9x. These two will cancel out, leave us with 0, and we'll be left with 9x. Now we're not done because we still have an x inside the house, so add your placeholder with the one lesser exponent. I just wrote down 0x. And then we can be like, all right, what can we multiply 2x by to get rid of 9x? Well, we can actually multiply by a fraction. So that's what I'm going to do. 9 divided by 2. And you'll see how this plays out later. How this plays out. Because if we do 2x times 9 divided by 2, we're going to get 18 divided by 2x plus 3 times, 9 divided by 2, 27 divided by 2. And all subtracted. This cancels out because 18 divided by 2 is 9. 9x cancels out with the 9x up here. And we're left with negative 27 divided by 2. That is our remainder. And remember, remainders are fractions. So our remainder is going to be negative 27 divided by 2 divided by our denominator, right? Because it's just a fraction. So 2x plus 3. Awesome. Now we can plug in all of this into our antiderivative. So I'm going to write out, push this back up, the antiderivative of 2x squared minus 3x plus 9x. 9 divided by 2 plus, or it's actually a negative. Sorry about that. Minus 27 divided by 2, all divided by 2x plus 3 dx. So let's just do normal anti-deriving. The antiderivative of 2x to the power 2 is just going to be 2x to the power 3 divided by 3, because whenever you're taking the integral of x, you just add 1 to the numerator, or no, you add 1 to the exponent and then you divide by the sum that you found for that exponent. So 2 plus 1 is 3, and then you just divide that by the sum, which is still 3. And then let's do the same thing for 3x. So remember, it's a negative, right? Negative 3x plus 1 in numerator gets you 2, and then divide by 2, because that's what you found. Now we're dealing with 9 divided by 2. The antiderivative of that is literally just 9 divided by 2x. Since you are adding or subtracting by a constant and you're taking the antiderivative of that, you just multiply by x when you take the antiderivative. Now, this one is a little funny because that's really hard to just take the antiderivative of by itself. So we're going to return back to past lessons and be like, hey, I can change this into something that's a little easier to antiderive by using use substitution. And I'm going to rewrite it like this, so that way it's a little easier for us in the long run. So ignoring this section, we are going to be looking at how to antiderive negative 27 times 1 divided by 2x plus 3 dx. Identify our u's first. U is going to be our innermost function, which is 2x plus 3. If we take du of this, the derivative of u, we're going to be left with 2 dx. Now we have to isolate the dx here because we don't really have a 2, and we need to, replace all the things with a u substitution term. So to isolate dx, we're going to divide both sides by 2. These cancel out, and you're left with du divided by 2 is equal to dx. Now we can plug this into our u sub. So the antiderivative of negative 27 divided by 2 times 1 over u, because that's what we said u was, times du divided by 2. Now we should start moving our constants that we're multiplying by outside of the antiderivative. So it's going to be negative 27 divided by 2, and then this right here will actually move as well. So times 1/2. And they're outside of our antiderivative, and now we are just left with 1 over u times du. And then remember from our antiderivative rules that the integral of 1 over u is going to be equal to ln u, right? And then don't forget your constants up here. I'm just going to combine them and call it negative 27 divided by 4 times ln u, and don't forget your plus c. That's really important. Never forget plus c. And then we can plug back in our equation that we found for u. So it's going to be negative 27 divided by 4 times ln the absolute value of 2x plus 3 plus c. Awesome. Now we can plug this back into the equation up here. So it's going to be negative 27 divided by 4 ln 2x plus 3 plus c. Okay, so yeah, that's actually as far as I think it goes. And that should be your answer for the integral of 4x to the power of 3 divided by 2x plus 3.